27th of June 2024. I'm just going to demonstrate the fine tuning I did for the past 1 or 2 days. So basically there's some big changes I did in terms of the RAG pipeline. Namely, first let's talk about the data. So the data, I reduced the size of data. Before it had a lot of data sets, so around 90 megabytes. I adjusted a bit. It was around, actually before it was around 164 megabytes of textual data. Now just testing on just the three main documents that we have here, which is around just 70 megabytes. So just less documents, just the main ones, which is this engine that we're trying to do. So one of the main changes that I did is I changed the function here, recursive character text bidder, into Spacey text bidder. So Spacey is a pretty well-known natural language processing Python package that is pretty cutting edge. So they have quite good functions just to study text. And before it was just based on like some random chunk size or some chunk overlap. So I decided to do this one. I think it will give a better response. Now, something I tested is the chunk size. So before it was 800. I reduced it to 400 now. So to explain chunk size, imagine we have this engineering manual here. Let's say we chunk an entire page, but chunking an entire page may not hold the entire meaning of it. So I decided to reduce the chunking. For example, chunk it based on a small paragraph like this. So if we chunk it based on a small paragraph, we can retain more information, but it will have a high training rate. But by retaining more information, we can improve its accuracy and reliability. So that's why I reduced the chunk sizes. So the chunk overlap as well, just based on what recommended is like 20 or 30% of the chunk size. So chunk overlap just helps maintain its context when it goes to like the next chunk. It reads back the previous one, just try and maintain the context. So I tested on a few things. So the first one was around 50 chunks. So that took over 10 hours. So that was not it took too long. But I think maybe it'll have better reliability. But then I tested 200. It took over 6 hours. So now I just tested the current one, which is 400, which is around 3 to 4 hours, which is kind of optimum in my opinion. So another thing that I tested was the separator. So separator, it kind of tells where the chunk will stop. So imagine separator is a full stop here. But normally people do like space or some special like some other thing like semicolon that I saw in some uh, of the like the data here. So it's good to kind of base it based on like some unique separators, so it can help maintain its chunk sizes. So if you see here, like not I specified 400, but it's maxing out above it. So doesn't mean it's bad, it just means that maybe it's not optimum. So that's something you can do, but unfortunately this function doesn't have additional separators, so you have to code it in yourself, but I didn't spend time doing that. So that could be an improvement here, possible improvement. Now in terms of pipeline, this is something that our functions can use. So the pipeline, this one is Spaces. I used the large English core web language pipeline, so you can see there's some pretty good components to kind of study the chunks. So and also like so that's a pipeline components, and also like you can see how it's stored in terms of its sources. So like one of it's from like Princeton University in terms of where it's studied from. So so WorldNet. So this is pretty one of the pretty good ones. So that's pretty good in terms of the pipeline. So that's the setup for just like the chunking. Now I'm going to talk about the embedding function. Hello again, it's Rizwan. So in this embedding function, one of the three new things I introduced was the top K, top P, and temperature. So basically, the top K, just a comment I did here is that before it was around 40, so I reduced it to 20. So when you reduce the top K of the embeddings, it really constrains the model, so it doesn't really like kind of make some creative things like ChatGPT. Normally it would be more factual. But I also didn't put it to set to 0 or 10 because I don't want it to like focus too much on it. So if, in my opinion, I think if you put it 0, it might not be confident of answer and might not retrieve it, but the answer might be in the text. So I think like around 20 is optimum for the top K. The top P also increases the creativity. So top P is a attribute that works aligned with top K. So basically increasing the creativity in retrieving the answers from this attribute here. So that's why I increase it so that it kind of works along maybe better in here. Also temperature is another function. So you can get all these here, by the way, in terms of the LangChain. So temperature, what they say here is it answers creatively. So default is 0.8. So I want to reduce the creativity of responses to 0.7 because if we're working with very factual data, we don't want it to be very creative and say something out of the box. We want it to be constrained and give us factual information. So that's something I did in terms of the embeddings function here. Hello. Another thing I added as well is the K attribute here for searching the database. So I increased it to 30. Before it's around 4. So when it's a low number like 4, basically it just retrieves maybe, for example, like four pages of a PDF document. But maybe there's more context around like around the document. So to give a better idea, perhaps we can go through a document here. So maybe you ask why did the fire release? Maybe it will retrieve only like the top these ones because these ones had the most contextually relevant maybe score. But perhaps that there is another better one, but maybe less contextually relevant, maybe somewhere down here. But the RAG model didn't think it was important based on the score. So um, increasing it to 30, perhaps we can get more information from the dataset and push it into our query response. So 30, in my opinion, maybe perhaps it's some people think it's too high. So I think we can do some more testing to kind of see uh, maybe an optimum number if the responses might not be too good. So this is just something I want to try just to increase the amount of information it gets when it retrieves information for us when we do a query. So maybe perhaps it's more contextually important as well. So this is another thing I did. Hello, now I'm going to do a comparison of before and after the fine tuning. Both of them had the same query, which is why did the CO2 discharge nozzle release in the LM2500 gas turbine of the Navy vessel? So before the fine tuning, we can see that the language model tried to rule out some issues about high speed or compressor malfunctions and saying that the symptoms don't indicate any significant problems with the gas generator or compressor or turbine sections of the LM2500 engine. So, well, I'm not sure if this is true, but it kind of just made this up right now. So this we can't confirm. So the after fine tuning, we can see that it says the CO2 discharge nozzle is a critical component of the LM2500 gas turbine. So basically, this is more factual and it's kind of grounded because it doesn't really diverge from the context. So when having these type of responses, we don't really want to diverge and add additional things that we're not uncertain of because it can cause dilution in our response for the further next context generations. So I'd say that after fine tuning would be much more reliable in terms of its responses. In this section here, it's the hypothesis generation. Before we could see the hypothesis, the LM tried to kind of guess, saying that it's maybe high loop oil temperature or gearbox scavenge temperature or oil leaking and dripping into the accessory gearbox. So maybe that could be a part of the problem, but perhaps it's way too general. Maybe this is a very, very low level type of point of view, or maybe it's not even accurate as well. If you think of, in terms of like, what if oil leaks from one compartment to the other? Would that really trigger a CO2 gas canister to release? Logically, maybe, but I don't think so. But I'm not a subject matter expert, but I think that maybe it's too outside the box in terms of the creativity. Now, in terms of after, I would say that this can't demonstrate root cause analysis capabilities, and these type of the after fine tuning, the response is kind of a more of a senior engineer. So you can see like, oh, maybe an engineer says icing condition at the gas turbine inlet might cause some damage. It caused some damage, or temperature exceeding as well. So that's true. Automatic shutdown initiated to default. So maybe a shutdown of another compartment of engine is because it's faulty that triggered a CO2 release of another compartment. That could be happening. Field flashing failure or malfunction. I'm not too sure what that is, but perhaps it will tell more in the explanation side. So before we can see, this is the explanation of each hypothesis. So the first one, it's thermal overload. So the high lube oil temperature and accessory gearbox scavenge temperature could indicate excessive heat generation in the accessory gearbox, potentially caused by increased bearing wear, inadequate cooling, or incorrect lubrication. This thermal stress might have led to malfunction or failure of the CO2 discharge nozzle, causing it to release. I'll say that is possible as well. That it's very general in my opinion. They could be possible. Let's see the icing. So icing conditions at the gas turbine inlet would cause inadequate air filtration or clogged airflow paths leading to icing conditions. Perhaps maybe like a icing, I would say maybe like for example, maybe the coolant that they use is sub-zero temperature that might cause some issues. Um, Solution: check and clean air intakes, ensure proper airflow, and verify correct functioning of air filters. So it's trying to do a root cause analysis in this when it has a hypothesis here. But on the left hand side, maybe maybe it's kind of very general. Maybe it could be true. I'm not too sure, but I much prefer the right hand side one because it seems more believable. On the left hand side, we can see this one's in terms of mechanical stress. So before, I was hypothesizing the oil leaking from the VSV and dripping from the accessory gearbox could suggest mechanical issues within gearbox or scavenging system. A faulty worn-out bearing might have caused vibration that stressed the CO2 discharge nozzle, leading to its release. Um, Maybe that could happen. I'm not too sure as well. That might happen. The right side after maybe has some root cause analysis. So it says temperature exceeding set point, overheating due to faulty temperature sensors, incorrect calibration, or malfunctioning cooling system. All of these, I would say, is possible to trigger the temperature to increase and trigger the CO2 canister. Solution: verify temperature sensor accuracy, check cooling system functionality, and adjust as necessary. So this is very interesting because it's now telling us to verify the accuracy of the sensors um, of the temperature. So that's very interesting because maybe in the pamphlet or in the manual it does tell you to do that, but on the left hand side maybe it doesn't really tell you to do that in the manual, but the right hand side I trust them more actually. So this one I'll say it's passed, so it's pretty good. On the left one we have loop oil pressure or flow issues. No to low loop oil pressure or high pressure could indicate problems with the lubrication system. If the lube oil pressure is too high or too low, it might affect the operation of the accessory gearbox scavenging system, leading to malfunction of the CO2 discharge nozzle. That could happen if there's not enough lubrication in in an engine that might generate too much heat. I think that is entirely possible as well. So this might be a possible scenario. So this could be maybe very creative. So the right hand side we see automatic shutdown initiated due to fault. Maybe there was automatic shutdown because there was a faulty in another section of the engine. Could be possible. So the root cause: faulty or malfunctioning sensors, control systems, or actuator components triggered an automatic shutdown. Check all sensors, control systems, and actuator components for proper functioning. Verify correct calibration and maintenance of these components. So when it says this, I find it very interesting because, namely, when it tells you to do these things, it wants you to go to the root cause analysis first and find the where it gets its information from, and then check the information, see if it's accurate. and see if maybe that breadcrumb data might trigger a fault. So perhaps from an engineer point of view, maybe this language model might you know answer and help the junior engineers to do these low level tasks, just to check the sensors, to let them know about what's happening. So if they can't solve these lower level things, that information gets passed towards maybe a high senior naval engineer, which can go further in depth, like on the left hand side. It's very in depth, but it might not be correctly in the right area. But the right hand side, possibly it can help the junior engineers, in my opinion. So I like the right hand side one better as well. Yep. So the previous one, it had three hypotheses. This is the fourth one from the fine tuning. So we can see that it says field flashing failure or malfunction. Root cause failure or malfunction of the three-phase full-wave bridge rectifier or blocking diode, causing a loss in excitation voltage. Check the rectifier circuit, replace any faulty components, ensure proper function of magnetic amplifier and excitation source. So maybe the language model here is saying that perhaps there was a voltage electricity that triggered something. So perhaps it's very interesting. It goes and try to maintain this route of saying that a component of the actuators or the things that gets its information, like the sensors, is causing the problem. Most likely, I would say that could be the root cause, because the sensors and stuff, maybe they're more likely to break because there's so many sensors. Maybe one sensor is faulty, and then it might trigger something instead of like entire block of an engine just breaks, like what the previously the fine tuning language model is kind of leaning towards. So this one I like more because it's more beneficial towards low level engineers which need more help and have probably more time than the senior engineers. So this one I'd say is quite good. And over here, it's a very simple one where it tries to give you the solution to fix these problems. So before it says this verify condition functionality of the system components. Yep, that's good enough. Check the loop oil pressure. That's good. Inspect gearbox, review engine operating logs and maintenance records. Identify potential contributing factors such as excess load on operation. Maybe. I think uh, this could be correct. After fine tuning, conduct preliminary inspection, identify potential cause of malfunction, verify correct functioning of air inlets, intakes, pass filters, check temperature, inspect cooling system or repair as required, verify proper functioning of sensors, control systems, and actuator components, conduct for maintenance check on CO2 discharge nozzle and surrounding components. Yep, that's true as well. Consult relevant technical documentation and seek expert advice if necessary. So perhaps the solution can be improved. Maybe there could be some type of control prompt to guide it towards a standard operating procedure, so that maybe over here it's kind of just basing on logic based on previous responses that we had in the hypothesis. Maybe we want them to actually retrieve the actual standard operating procedure and give the actual output, but in a more end user friendly way. So yeah, both of these has pros and cons. Perhaps after fine tuning, I would say the fine tuning definitely can provide a more reliable and more believable response. Yep. So thank you for watching.